Hey guys, this is Miss Stewart. Testing this out, kind of seeing how it's going to go when I'm out on maternity leave. I am at a doctor's appointment today, so just bear with me and we'll just kind of see how this goes, okay? All right, so you should have a handout that looks just like this, and it's a packet. It's pretty thick. But if you will, take a minute and write down these two quadratic equations. We have been working on solving quadratic equations by factoring. So we're going to do that one more time right here. Okay? So I have this equation, 81x squared minus 121 equals 0. Well, I recognize that I have two terms and I do not have a GCF. So what I'm going to do, I'm going to look. I see that this is a subtraction problem. I also recognize that 81x squared is a perfect square. And I also recognize 121 is a perfect square. So I know that this is a difference of squares. Now this comes from studying that foldable and knowing how things are going to factor. In this one, there's going to be a plus in one and a minus in the other. What is the square root of 81x squared? Square root of 81 is 9, and the square root of x squared is x. So I'm going to have a 9x in the front position for both of these. And then the square root of 121 is 11. Now, I've got it factored, but notice it's set equal to 0. So this is the part where I take what I've got and I break each piece apart. I've got 9x plus 11 equals 0, and 9x minus 11 equals 0. And I'm going to solve each equation. This one, in order to solve for x, I need to remove the 11. To move a plus 11, I'm going to subtract it from both sides. So I know that that would give me negative 11 over here, and I would have 9x still left on the left-hand side. Well, how do I get rid of the 9 in front of the x? I divide it. So x equals negative 11 ninths. On this one, I would start out by adding 11. So that's going to be 11, positive 11 on the other side. And I would divide by 9. So my two solutions to this quadratic equation are positive and negative 11 ninths. Okay? All right, take a second and jot down equation number 2. I have 6x squared minus 2 equals x. Well, one thing we have said is that every single quadratic equation has to be set equal to 0. So I'm going to take this x right here and I'm going to move it to the other side. I'm going to rewrite this as 6x squared. Now over here this was a positive x, so over here I'm going to have a minus x and then minus 2 equals 0. All right, so notice I did not combine anything because x is not the same kind of term as x squared. They're not like terms, so I cannot put them together. So the next thing I'm going to do, I'm going to see if there's a GCF. I do not have a GCF because this is negative 1 right here. Okay, so I am going to get my x set up. I'm going to do my fractions on the left and the right. And I'm going to put a 6x on the top of both of those fractions. Now to start solving, because I have a leading coefficient of 6, I have to remember that I have to slip and slide. So 6 times negative 2 is negative 12, and that's going to go up top. And then my b value is negative 1. Well, what are the two values? What are the factors of negative 12 that are going to add up to give me negative 1? Well, I know that a 4 and a 3 will give me a 1. but that 4 has to be negative in order for that to be a negative 1. So I've got all my stuff set up. Now I need to check and see if these fractions will simplify. The 6 and the negative 4 have a common factor of 2. So if I divide out a 2, that's going to give me a 3 right here and a negative 2 on the bottom. Whereas over here, the 6 and the 3, I can divide out a 3. All right, so one of the things I noticed yesterday was that we wanted to just cross those out and put the 2 up here. We cannot forget that I have to have a placeholder. So there has to be a 1 down here in the bottom. So this factors into 3x minus 2 times 2x plus 1 equals 0. This is where I'm going to take my 2 factors and set each piece equal to 0 and solve. Okay, so the first thing I would do for this one, I would add 2 to both sides. So that's going to be a positive 2. And then to get rid of this 3, I'm going to divide it. Over here, to get rid of this plus 1, I'm going to subtract 1. And to get rid of this 2 that's still attached to the x, I'm going to divide by 2. Okay? All right. So there are your 2 factoring questions that we're going to use as our review today. The next question says, how do you remember the order of operations? Well, I remember it from elementary school as please excuse my dear Aunt Sally, the PEMDAS, okay? So the one thing I need to remember is that multiplication and division are worked out from left to right, and so are addition and subtraction, left to right. Now here's the one thing that I want to point out. When we are working on evaluating, okay, I'm going to follow the order of operations this way. So when I'm trying to plug something in and work it out, I'm going to move in this direction. But when I am trying to solve an equation, I have to work backwards. Okay, so I would do addition and subtraction, and then I would undo multiplication and division. Okay, and then we'll take care of exponents and parentheses if I am solving. Okay, so we're going to need to remember our order of operations as we start solving quadratics by the square root method. And that's what we're going to do today. This is very, very simple. Okay, we just have to make sure we follow our order of operations. So if you will, take your paper and let's flip it over here real quick. Okay, let's do a quick quadratics review. What does a quadratic function look like? Well, our functions are usually written in function notation. F of x equals ax squared plus bx plus c. Okay. My functions also can be graphed, and I need to remember that these graphs are what we call parabolas. It can open up, it can open down. And we'll talk a little bit more about that as we move on. Okay? A quadratic equation is what we've been working on. I have this ax squared plus bx plus c equal to 0. An equation has an equal sign, and that equation is always going to have to be set equal to 0. Okay? Excuse me. All right, what are 3 synonyms for solutions. We talked about this a little bit the other day. There are 3 words, or 4 words technically, that can be interchanged with each other. So we've got solutions, we have roots, we have zeros, and we have x-intercepts. Now I'm going to make a connection here. My x-intercepts are going to be connected back to those graphs, okay? And then how many solutions do quadratic functions have at most? Talked about this the other day. The highest power of my equation here is 2. That number is the most number of solutions that I can have overall. If my highest power had been 5, I could have 5 solutions. But we're not quite there yet, okay? All right, so the next page. Here are some different methods that we can use to solve quadratic functions, okay? We have already talked about factoring. Solving quadratic equations by factoring. That's when we set it equal to 0 and break it apart into these parentheses and set it equal to 0. Okay, we have another method called completing the square. You did this a little bit in geometry last year, but we're going to avoid this one for right now, okay? This one isn't very helpful to us. We're also going to talk about the quadratic formula, and that's what we'll get to next week. But the one we're going to focus on today is the square root method. What do you notice is different about these 2 equations? I see one thing. This one has bx, and this one does not. So there is no x term. I do have x squared, but I don't have that bx term in the middle. So technically, this one could be rewritten as ax squared plus 0x plus c. But anything times 0 is just 0, so that really can be avoided, okay? All right, turn it right here. And here are my directions. 3 simple steps. The first thing I want to do is get the x squared term alone. I want to isolate it, okay? After I do that, I'm going to take the square root of both sides to solve for x. But one thing I want to remind you of, when I take the square root, I cannot forget that I'm going to have a plus or minus in front of my equation. So let's talk about that, okay? Right here, example number 1. The first thing I want to do is get the x squared term alone. If you'll notice right here, it is alone. There's nothing that I have to do to that. So the next thing I need to do is take the square root of both sides. Well, when I take the square root of something that has been squared, that square just disappears, or the radical disappears. What is the square root of 25? It's 5. But I want you to think about something. If I am taking this number and plugging it back in to check it, 5 squared is equal to 25. That is true. But I can also take a negative 5 and square it, and it gives me a 25 also. So right out in front of this answer, or the solution that I got, I'm going to throw a plus or minus, which means positive 5 and negative 5. There are 2 solutions to this equation, okay? So plus or minus is going to be very important to us here. All right, example number 2. I have x squared by itself, so the next thing I'm going to do is take the square root of both sides. Okay? This just gives me x. The square disappears. I'm going to go ahead and I'm going to put plus or minus because I don't want to forget this. I notice that I've got a negative under my radical. Well, those negatives under the radicals did not stay away for long. Anytime I have a negative under a radical, I need to remember that I can remove it and turn it into an I on the outside. And then I'm going to take this 32 and I'm going to simplify my radical. 32 breaks down into 8 and 4. 4 is a perfect square. And this 8 continues to break down again into 4 and 2. 4 being a perfect square. The square root of 4 is 2. The square root of this 4 is 2. I'm going to multiply the two 2's together that I take out. Now this 2 that's left over is going to go back under the radical. So my final answer is x equals plus or minus positive or negative 4i square root 2. So if I were to write this out as a solution set, I could say 4i root 2 and negative 4i root 2. But I really want to avoid having to write it multiple ways. So I'm going to simplify it by sticking with this, okay? So I'm going to come right here, and I'm going to put a box around my final answers. Okay? All right, look at example number 3. Notice here, I have a 2 attached to my x squared, and I do not want that. I want my x squared term isolated. So this is 2 times x squared. I'm going to start out by dividing both sides by 2. Okay? So x squared is equal to what? 54 divided by 2. I don't have my calculator with me, and my math brain is not working very well, so I'm going to come do long division. Oops, that should be a 4. Okay, so I see it is 27. Now, I'm going to take the square root of 27 on both sides. Hold on just a second. Okay. All right, now 27. I'm going to take this and I'm going to break it down into 9 and 3. Now 9 is my perfect square. So right here, the square goes away. I took the square root, so I'm going to throw a plus or minus out there. 9, the square root of 9 is 3. And then this 3 that's left over is going to go back under my radical. Now, if you'll notice with this equation, there was no negative under the radical, so I do not have an I in my final answer. And this would be it. Okay? All right, so let's flip the page real quick, and let's look at a couple more examples. This time, I have plus 6 attached to my x squared. Well, how do I get rid of a plus 6? I'm going to subtract 6. So here I have x squared is equal to negative 38 minus 6 more. I'm just going to add these two together. That is going to give me negative 44. And I'm going to take the square root of both sides. Even though that's a negative, we can simplify that. So on the left side, I get x. And I'm going to go ahead and I'm going to do my plus or minus. Right here, this negative under the radical, when I take it out, what is it going to turn into? It's going to turn into an I. And then I'm going to take the 44 and break it up. I have 4 times 11, and 4 is my perfect square. So I'm going to take the square root of 4, which is 2, and take it on the outside. And then this 11, nothing happens to it. It's going to go back under the radical. So my final answer here is x equals plus or minus 2i square root 11. Okay? On example number 5, notice I have a combination of two things, but I want to remember when I'm following my order of operations, okay, I put the little PEMDAS thing here. I'm going to work it out this way when I'm evaluating, and I'm going to go backwards when I'm solving. So the first thing I'm going to do is undo addition or subtraction. So here I'm going to subtract 5. So I get 3x squared is equal to, let's see, again, I don't have my calculator. My math brain kind of stinks tonight. All right, this is going to be 8, and that's going to be 4. So 3x squared equals 48. Now I need to undo the multiplication or division. I need to divide both sides by 3. So I get x squared equals 16. I know 3 times 16 is 48. All right, and then right here, I've got the x squared term isolated. It's all by itself. So I'm going to take the square root of both sides. That gets rid of the radical and the square. And then over here, I've got plus or minus, and the square root of 16 is 4. So my answer is positive 4 and negative 4. Okay? Hopefully we're doing okay so far. You can certainly pause the video at any time you need to so that you can go back and rewatch. Okay? All right, here we go. Now, I do want you to understand the difference between an exact answer and an approximate answer. An exact answer will be left in radical form. So for example, back here on example 4, I had a radical left in my answer, okay? So this is an exact answer. But if I were to type that in the calculator, or maybe example number 3, 3 square root 3, it's going to give me a decimal, which would be my approximate answer, okay? I tend to leave everything as exact answers as much as possible, okay? I really don't want those approximate answers unless it specifically asks me for that, okay? All right. A couple more examples that we're going to look at together. All right. This right here, this looks familiar. This technically is a difference of 2 perfect squares. So I could factor it with a plus in one and a minus in the other. But since we are specifically solving by the square root method, I'm going to choose that way today. And that might actually be easier in the future for you. All right. So the first thing I'm going to do is isolate my x squared term. I'm going to start by undoing the addition or subtraction. So I'm going to move this negative 64 over to the other side, and it's going to become positive 64. Then I'm going to divide by 9 on both sides so that I get x squared all by itself. Now, I know we created a fraction, and nobody likes fractions, but these are pretty numbers. So when I take the square root of both sides, please remember, you are going to take the square root of the numerator and the denominator individually. So the left side of my equation, the square is now gone. Because I took the square root, I've got a plus or minus. And then here, the square root of 64 is 8. And the square root of 9 is 3. So x equals positive and negative 8/3. Okay, so these next two might be where it gets just a little bit tricky. I want you to notice that I've got these parentheses. I cannot touch anything inside these parentheses until I get rid of this square. Okay, they're kind of protected by that. So I'm going to start out here because my square term is the first thing I can do. I need to start out by taking the square root of both sides. That's going to eliminate my square. And what that does is just leaves me with what I had under the radical, which is x plus 3. Now over here, I've got a radical, so I've got plus or minus, and then I've got an I because of the negative, and then the square root of 9 is just 3. So right here I have plus or minus 3i. The very last thing that I'm going to do is I want to get x all by itself, okay? So I'm going to take this plus 3, and I'm going to move it to the other side. But I am always, anytime I ever move anything from one side to the other, I always want to put it out in front of my plus or minus. So right here, I'm going to subtract 3 from both sides. So x is going to be equal to negative 3 plus or minus 3i. If you'll notice, this right here is standard form of a complex number. Remember, a plus bi. Mercy, y'all. I'm so sorry. I hope that this is gone by the time I come back to you. Okay? All right, example number 8. Notice this minus 6 is on the outside of these parentheses right here. So I'm going to go ahead and I'm going to move this over here. So I have 5x squared. And that's going to be equal to, let's see, negative 26. I think that's right. Okay. Now, in order to do anything right here, I cannot touch the 5 until I get rid of the square. So I'm going to take the square root of both sides. When I do that, I'm left with 5x equals plus or minus. All right, here, I'm going to go ahead and simplify. This is going to turn into an I. And then 26 only breaks down into 13 times 2, and neither one of those are perfect squares. So I'm actually just going to leave that square root 26 underneath the radical. All right, and the very last thing that I need to do, I need to get this 5 all by itself. So I'm going to divide both sides by 5. And I'm going to rewrite it over here to the side. I get x equals plus or minus I square root 26 over 5. Notice I made this over 5 like the whole denominator of that whole fraction. Okay? All right? All right, 2 more examples, and then I'm going to have you just kind of try and see how you do, okay? All right here. I got to work my way from the outside in. So I cannot touch anything on the inside of the parentheses until I get rid of the square. But notice I've got a 3 and a 2 that I need to get rid of. The first thing I'm going to do is I'm going to subtract 3 on both sides. So that's 2 times x minus 4 equals, let's see, 53 minus 3 is 50. The next thing I'm going to do is divide both sides by 2. So that's going to leave me with x minus 4 squared equals 25. All right, now I like the number 25, especially since it's not negative, okay? Can't do anything else until I get rid of the square root. So when I take the square root of something that has been squared, I'm just going to get whatever was under that radical to begin with. Now, I took the square root of 25, which is 5, but I cannot forget the plus or minus. Okay? The last thing I need to do here is move this minus 4 over here. And I'm always, always, always going to write it out in front of the plus or minus. It was a negative 4 on this side, so when I move it over, it's going to be positive. Now, call me crazy, but I can add 4 and 5, and I can subtract 4 and 5. So this right here, I've got two situations. I have x equals 4 plus 5, and I have x equals 4 minus 5. What is 4 plus 5? 9. And what is 4 minus 5? Negative 1. These two numbers are my solutions. Sometimes they give me the pretty plus or minuses, but when I get the pretty square roots, sometimes I'm going to get two numbers that don't look anything alike. Okay? All right. Last example right here. I've got some stuff on the outside of my parentheses, so I've got to take care of the outside and work my way in. Okay? First thing I'm going to do, I'm going to add 6 to both sides. So I've got negative 6 times x plus 2 squared. And then 48 plus 6 is 54. Then I'm going to get rid of this negative 6. When I divide that by negative 6, I'm going to get x plus 2 squared equals negative 9. All right, then I've got everything down to where the square is the only thing attached right now. I'm going to take the square root on both sides. So that eliminates the parentheses and the square. I've got x plus 2 equals, all right, well, I know that the square root of negative 9 is plus or minus 3i. And then I'm going to take this positive 2 and I'm going to move it over to the other side so that I get x all by itself. So when I move this positive 2 over, I'm going to get negative 2 plus or minus 3i. There's nothing I can do with these because this one has an I and this one does not. Okay, so it's in standard form. I know that's my final answer and I'm good to go. All right, so I've taken you through 10 examples, okay? Every example has been slightly different. So what I would like for you to do, I would like for you to refer back to examples 1 through 10, and I would like for you to look at this ticket out the door. Please make sure that you write your name on your paper, today's date, which should be September the 4th, and then if you will write your class period, okay, 1st, 2nd, 3rd, 5th, 6th, or 7th, all right? And I want you to take each problem and work it out, okay? You're going to do this on this sheet of paper. You're not going to pull out any scratch paper. You can flip back with your notes and look at that. But if you will tear this page off the back, you are going to leave this in the classroom today. So, for example, I'm going to take number 1 and I'm going to rewrite it so that I can show my work in this area. And then I might do number 2 here and then do 3, 4, 5 on the back. Okay, circle your final answers. Excuse me. Do your best. Okay, I understand this is the first day that you have seen this since 9th grade, It's been a while. But use your examples to help you work back through these things, okay? You may use a calculator, but don't depend on that calculator. You'll see that I use long division to help me with some of mine. After you are done, please turn this in to my desk, and you are going to receive your blue week 5 homework in return. That is a quiz review, and it will count as a daily grade. It will be due on Friday, and it will be taken up at the beginning of class. Just a reminder, it does absolutely no good to do a review after you take a quiz, okay? I will be back tomorrow, and I will answer any questions you have. We'll work through some problems and kind of just see where we are, okay? You do have a quiz on Friday. I hope you have a great day, and I will see you in the morning or tomorrow afternoon. You'll have a great day. Bye-bye.